Let's work out some objectives based on this session. Here is the first one. The number of neutrons present in 19K39 is. So what is 19? 19 is the atomic number of an element. What is 39? 39 is the mass number of the element. How to calculate number of neutrons? Number of neutrons, that is equal to A minus Z. What is the A value given? 39. And what is Z value? 19. So what will be the answer? It is 20. Option C. The nucleus of an atom whose atomic number is greater than 1 consists of, is it only proton and neutron, proton and electron, neutron and electron, or all the three? So why specifically here it is mentioned atomic number greater than 1? Because when we take the case of element with atomic number equal to 1, it is nothing but hydrogen. It is nothing but hydrogen. And we know that for the simple hydrogen or the normal hydrogen, we write it as 1H1. So it has only one proton and one electron, and there is no neutron. So the only element in the universe without the neutron in its nucleus is the normal hydrogen or the protium. So that is the reason why it is mentioned as atomic number greater than 1. So what is the answer now? The nucleus of an atom consists of definitely nucleons. What are the nucleons? They are the protons and the neutrons. So answer is option A. Let's move to the third question. Here it is. The number of electrons in a neutral atom of an element is equal to its. What will be the answer? It's simply the definition of atomic number. Answer B. As this is a basic session, we have very easy questions in this particular session. The fourth one. The specific charge of the canal race. Option A is not constant but changes with gas filled in the discharge tube. And another option remains constant irrespective of the nature of the gas in discharge tube. And the third option is maximum when gas present in discharge tube is hydrogen, and they are given value for the fourth option. Now here we know that in the case of the cathode rays they are nothing but the stream of negatively charged particles, that is the electrons. So irrespective of the gas taken in the discharge tube, the specific charge of the cathode rays remains the same. But that is not the case for the anode rays. Why it is so? Because based on the gas taken in the discharge tube, the positive charges will change or the positive rays will differ. If the gas taken is hydrogen, then only the positive rays contain protons, that is H+. So that is the reason why here the answer is the specific charge of the anode rays is not constant but changes with gas filled in the discharge tube. This is one answer. And one more answer is there in the same question, that is the specific charge for the anode rays is maximum when the gas present in the discharge tube is hydrogen. Because here we know that the specific charge is the ratio of the charge to the mass. As proton or as hydrogen is the lightest element that possesses the smallest mass, and whenever the mass value is the least, definitely the final answer, that is specific charge, will be the maximum. So for this question the answer is both option A and option C. The next one. Proton. What is proton? How we will get proton? Yes, what will be the answer? It is removal of an hydrogen, removal of an electron from hydrogen atom. And once we remove an electron from hydrogen atom, it is nothing but the ionized hydrogen atom. So answer is option C. The sixth one. According to the Rutherford, which statement is correct? First one, electrons revolve in fixed circular path around the nucleus. Second one, electron revolves around the nucleus. Third one, electron does not decrease its energy at the time of the revolution. Fourth one, electron obeys law of conservation of momentum at the time of the revolution. Now we know the first major drawback of the Rutherford model, that is whenever a charged particle is revolving under the influence of opposite charge, it should continuously lose energy. So the electron adopts a spiral path and fall into the nucleus finally. And that is the reason why these two options are wrong. Now at the time of Rutherford, he only concluded that electrons revolve around the nucleus as that of planets revolving around the sun. So there was no fixed circular path like the orbit which was later on proposed by the scientist named Niels Bohr. So that is the reason why the answer is not option A, it is option B. Then the seventh question. Rutherford scattering experiments led to the discovery of. So what was the end result of this Rutherford scattering experiment? It's not only the discovery of the nucleus but also indicated the presence of neutrons in the nucleus. So answer is both A and B.